Hey everybody, welcome to this week's second physical science lesson for distance learning. I'm Mr. Flugum, remember me? Hey, I haven't seen you guys for about a week and a half, but I'm back and I wore this shirt on purpose because it matches this PowerPoint. Yeah, just kidding, I'm not that good. It's just a coincidence. All right. So let's go ahead and get started, you guys. We're going to be talking about work and power. So this is a little bit of a shift from energy that we've been talking about, but not totally unrelated. In fact, work is a measurement of transfer of energy, all right, and has the same units as energy. And then power is a measurement of how fast energy is being transferred. So it still all relates to energy, and we're going to take these two concepts, you guys, and we're going to start to relate them to simple machines and devices that we use. So let's go ahead and get started here. All right, first thing is work, right? What is work? Well, a lot of times we talk about work as something that we do when we get paid, or we talk about it as something that's really hard or something that we have to do. Well, in science, we talk about work as being the transfer of energy when force is applied, and that's a really key thing about force. So let's kind of talk about that a little bit, okay? When we talk about force, right, and applying it, when we apply force, that doesn't mean we're always doing work. So this guy here is applying lots of force. Okay, he's trying to lift these weights, but he hasn't moved them yet. He hasn't transferred energy to these weights. They still have the same amount of energy because they're still sitting on the ground, right? So no movement means no work is being done. However, in this case, as the weight is lifted here by this person, the movement transfers energy to the weight, right? So that means work is being done. So this weight has a lot more GPE when it's up here than it does when it's down here on the ground. Therefore, as this person applies force, they are doing work. All right, so calculating work. Remember I said this is a way of figuring out how much energy is transferred. So we do this, right? Work is force times distance. Really simple, as with a lot of things in physical science. It's a short 2 or 3 variable equation. And the units for work are joules. And if you remember from Mr. Marquis' presentation on Monday, right, the units for energy are joules. So it's the same thing. So work is really just calculating a transfer of energy, like I said in the first slide. So let's check this out here. Got this guy. He lifted these weights way over his head. Here's the amount of force he used. Here's how far he lifted them. How much work did he do? Well, it's pretty simple, right? Plug stuff in. You got 800 newtons and times 2 meters. And that gives you 1600 joules. Okay, so in the process of lifting these weights here and applying this force, we transferred 1600 joules of energy to those weights. Okay, moving along here, we got power. Okay, power is a slightly more complex kind of idea, you guys. Power is how fast work is being done, okay? Or how fast we are transferring energy is another way to put it. Remember, work is transfer of energy, right? And the units for work are watts. And you may be familiar with watts. You hear about those when we talk about electrical appliances and things like that, right? And so, if you've got an 1100 watt microwave, that means it transfers energy faster than an old 900 watt microwave, okay? Stuff like that. And a 60 watt light bulb uses energy much faster than a 15 watt light bulb, and so on, okay? So power here, you guys, is work divided by time. So let me just show you a quick example here. We've got Joe Schmo and Joe's cousin Larry, all right? So Joe Schmo did 600 joules of work in 5 seconds. So if we do the math, right here, that means that Joe Schmo used 120 watts of power, okay? Now, Joe's cousin Larry did the same amount of work, right? 600 joules, but he did it in 10 seconds. It took him longer, which means we get 60 watts of power. He used less power, right? And so there's a difference there. Even though they did the same amount of work, right? They used different amounts of power because of how fast they did it, okay? So this is what makes this a little bit more complex, right? Okay, is figuring out, okay, when you get more watts, you do things faster and so on, okay? So let's look at another example that maybe might make this a little bit more clear. Okay, so I set up this little scenario here. We've got Farmer Smurf. I don't know if you guys are familiar with the Smurfs, but there's Farmer Smurf. And over here, this is Farmer Ed. Okay, they both need to get their hay onto this trailer here. Okay, and here's the deal. The hay has a weight of 900 newtons. Okay, so that's how much force they need to apply to get that hay up onto that trailer. The trailer is 1 meter off the ground. Okay, so two questions here. Who did more work? Well, if you look at that, we've got this amount of force, right? 900 newtons. And we've got this trailer here that's 1 meter off the ground. So let's do a little bit of math magic here. All right, so that means this. I got 900 newtons. I'll do my best to draw with my mouse here. 900 newtons times 1 meter. And we do the math. Boy, that's easy math, isn't it? That means we've got this, 900 joules. Now, since both Farmer Smurf and Farmer Ed had the same amount of hay, right, and had to put it on the similar trailer, right, did either of them do more work, or did they do the same work? Well, it sounds to me like they did the same amount of work, 900 joules. Now, the next question is this: who used more power? Well, if I look at this, Farmer Smurf did his hay bales in 45 seconds, and it took Farmer Ed 90. So who used more power, you guys? What do you think? Well, if you answered Farmer Smurf, you're correct, because he did it faster, right? Which means he transferred the energy or did the work faster because he used a shorter amount of time. So let's check this out here. We'll do a little math real quick. We've got 900 joules of work. And he did it in 45 seconds. That means this, right? That means we got 20 watts. So that's from Farmer Smurf, right? Okay. Now if we look at Farmer Ed, he did 900 joules of work. I feel like I'm doing a decent job with this mouse. I don't know if you guys have ever tried this before, but you know. So, and 90 seconds. Well, Farmer Ed only used 10 watts of power to do his work. Okay, so who used more power? Farmer Smurf, right? Farmer Ed only had 10 watts of power that he used. So remember this, right? More power means less time, kind of doing things faster. For those of you that are used to like weightlifting, right? This is like comparing a squat to a power clean, right? Squat, we might do really heavy weight, but it's a much slower movement. Whereas a power clean, right? We might not do as much weight, but it's a faster movement, so it's more powerful, right? Because the amount of time used to do the lift is shorter. Okay, so that's another way for those of you that are maybe in a weights class or are athletes or something and are used to doing that, to think about this. Okay, so let's wrap things up here, you guys. Here's what you need to know. You need to know how to calculate work and power. Okay, hopefully you wrote down the formulas, the things that were in red. Okay, you need to define work and describe when work is being done. Okay, so remember, you have to have movement in order for there to be work. Okay, and then you need to just define power and describe what increases or decreases power. So there's two factors there, right? Two factors when we talk about power. We talk about time and work, right? So increasing or decreasing power can do this, right? The amount of time that you take, right? You take less time, you got more power. Or if we do more work, we can also increase power, right? And then we need to use proper units for work and power. Okay, so remember work is joules, and whoops, let me go back, sorry. Remember work is in joules. Work is joules, power is watts. Okay. All right, well, thanks for tuning in, you guys. So there's two assignments you can choose from. One of them is kind of an activity where you do something, okay, but you need to have a hill or a set of stairs for you to do that on. The other one is just kind of a worksheet where you do some things and tell me some things about work and power. So make your choice there, and thanks for tuning in, you guys. I hope you have a great rest of your week, And we'll see you in a little while. Bye-bye.